Neurodegenerative diseases are a rising public health issue. Parkinson's disease affects over 15,000 people in Switzerland alone. Typically, it manifests in the brainstem before propagating all over the brain. The molecular mechanisms for this process are largely unknown. During this progression, certain vulnerable brain cells die. This disrupts normal function of brain circuits, which leads to the cardinal symptoms of the disease such as trembling and rigidity and eventually dementia. Previous studies in humans relied solely on postmortem tissue. This has the disadvantage that the tissue has been disintegrating for several hours and usually stems from patients in a very advanced disease stage. So how can we overcome these drawbacks? To treat symptoms, all patients receive medical therapy, and some patients can be treated with a surgical intervention called deep brain stimulation, or DBS. Here, an electrode is implanted into the brain for chronic electrical stimulation of the target area, the subthalamic nucleus, which is located just above the brainstem. However, DBS is not only an effective treatment, it also opens a window of opportunity. During the procedure, tiny amounts of live human brain tissue adheres to the surgical instruments. Usually, these instruments are discarded afterwards. In our unique approach, we slightly modified one of these instruments so that it's still safe to use, but we can ensure that the tissue stems from the subthalamic nucleus. This has the advantage of yielding live tissue much earlier in the disease. In this study, my aim is to characterize the cells of the subthalamic nucleus and how they're affected in Parkinson's disease. As they're affected early in disease, I want to investigate the molecular changes caused by the degeneration. This could shed light on the mechanisms of disease propagation and the dysfunction of brain circuits. To analyze the tissue, I perform single-cell epigenomic analysis. This means I look at which regions of the DNA of an individual cell are accessible to transcription. This allows me to deduct which cells I'm dealing with and in what health status a cell is in. As not all cells are affected to the same degree, I can reconstruct the failure of the molecular machinery that leads to the propagation of the disease and the degeneration of cells. Overall, this study will deepen our understanding of Parkinson's disease and provide a basis for better treatment in the future.